In the world of heavy industry, you see these massive pumps everywhere. They're absolute workhorses. But what's the one thing that keeps them from failing in a huge catastrophic mess? Today, we're diving into the inside story of a critical and honestly pretty heroic component, the pump seal.
I mean, these things are incredible. They move insane amounts of liquid in everything from power plants to chemical factories. But have you ever just stopped for a second to think about the fundamental engineering puzzle that's right at the very heart of one?
Think about it. You've got a shaft, spinning like crazy, coming out of a chamber that's full of high-pressure fluid. Every bit of logic says there should be a massive leak, right? But there isn't. And the reason why is just a masterpiece of engineering.
That's right. This small but absolutely crucial part is pretty much the only thing standing between a smooth operation and a total disaster. It's the shield that keeps all that gunk you're pumping away from the pump's motor and bearings.
So here's the basic problem we're trying to solve. Where that rotating shaft leaves the pump housing, there's always going to be a gap. It's unavoidable. The real challenge is, how do you seal that gap against intense pressure but still let the shaft spin freely thousands of times a minute? It's like a constant battle against physics.
So we're going to frame this whole thing as a classic matchup. You've got the reliable old guard versus the high-tech modern challenger. Two totally different ways of thinking, both trying to solve the exact same problem.
First up in the ring is the traditional workhorse, the stuffing box. This thing has been the go-to solution for decades. It's tough, it's been tested a million times over, and it's built on a really straightforward idea: compression.
Okay, so here's how it works. You take these rings of a special, flexible packing material, and you literally stuff them into the space around the shaft. Then, you use a piece called a gland to tighten down on them and squeeze them, which creates the seal. But there's a secret ingredient.
And that secret ingredient is water. Clean seal water gets forced right into the middle of all that packing at a pressure that's just a little bit higher. We're talking about 5 psi higher than the fluid inside the pump. This creates a barrier of positive pressure that's constantly flushing out any grit or abrasive bits and keeps the stuff you're pumping from getting into the seal area.
Now this is where it gets a little weird. This whole thing seems completely backwards, doesn't it? We're trying to stop a leak, but the solution actually requires one. So why on earth would you design a seal that is meant to drip?
Because that constant drip of clean water is the key. It is not a flaw, it's a feature. It's doing two incredibly important jobs. It's acting as both a lubricant and a coolant for that spinning shaft, carrying away all the intense heat that's generated by friction. Without that drip, the packing would literally burn up and the shaft would get destroyed. So technicians actually fine-tune the gland to keep this very precise, very minimal leak going.
So let's talk trade-offs. The big upsides are that it's cheap and it's simple. You can even repack it without having to take the entire pump apart, which is a big deal. The downsides? Well, that constant leakage, which can be a huge environmental or safety problem. It also needs regular adjustments, and you run the risk of seriously damaging the shaft if you over-tighten it.
All right, on to our second contender, the mechanical seal. This is the modern high-precision alternative. It's a whole different ballgame. It's less about brute force compression and all about sophisticated materials and microscopic tolerances.
The real magic of a mechanical seal is in what's called the lapped faces. Okay, picture 2 ice cubes, polished so perfectly smooth that when you slide them over each other, there's almost zero friction. That's the basic idea here. You have one face that rotates with the shaft and another that's stationary, and they are held together so perfectly and so tightly that not even tiny fluid molecules can get through.
So the key parts are these 2 faces, which are held together with super precise pressure from either springs or a bellow. And the materials themselves are, well, they're basically space age. We're talking about advanced ceramics, hard carbons, or even silicon carbide, which is almost as hard as a diamond. That makes them incredibly resistant to wear and tear.
Now, what about its pros and cons? The advantages are huge. We're talking essentially zero leakage, no wear and tear on the shaft itself, and it can handle way higher pressures and speeds. The trade-offs? It's got a much higher price tag up front, and the installation is incredibly delicate. I mean, a single speck of dirt can cause the whole thing to fail, and if it does fail, you're taking the entire pump apart to fix it.
Okay, so we've met our 2 contenders. On one side, the rugged, leaky stuffing box. On the other, the precise, delicate mechanical seal. Let's put them side by side. It's time for the final showdown.
You know, this right here highlights the core philosophical difference between the two. With the stuffing box, the challenge is all about continuous maintenance. You're always tweaking it, always repacking it. With the mechanical seal, the challenge is all upfront. You have to get that one-time installation absolutely perfect.
So let's really break this down. For the mechanism, you've got crude compression versus these elegant polished faces. For leakage, and this is a big one, you have a required constant drip versus pretty much nothing. No lost product, no environmental spills. For cost, it's low initial investment versus a high one. And for maintenance, you've got constant adjustments versus a major, painful replacement if it ever fails. It's the classic battle of operating expense versus capital expense.
So, after all that, which one is actually better? Well, the answer, as it so often is in engineering, is it depends. There is no single best seal. The right choice is completely 100% dictated by the specific job it needs to do.
So here's a quick cheat sheet for you. You'd probably stick with a stuffing box for older equipment or maybe in low-speed, non-critical situations where that low upfront cost is really the most important factor. But you're going to choose a mechanical seal every time for high-performance jobs or when you're pumping something hazardous or expensive or anything where even a tiny leak is completely unacceptable.
Ultimately, it all boils down to this one single trade-off. Are you willing to pay more upfront for a system that's going to require a lot less day-to-day attention, or do you prefer a lower initial investment, even if that means you're signing up for more hands-on maintenance over the life of the pump?
And that's really the final question you've got to ask yourself. In your world, for your project, what's more costly in the long run? Predictable, regular maintenance, or sudden, unexpected downtime? The answer to that question tells you everything you need to know about choosing the right seal. That's all for now.